Okay, page 7 of section 6-7. We're going to do some more examples to kind of bring it all together here. Scores for the California Police Officer Standards and Training Test are normally distributed. They have a mean of 50 and a standard deviation of 10. Right, we take the mean, we add 10 for each standard deviation, we subtract 10 for each -1 going down. Alrighty, and then the agency will only hire scores in the top 10%. Let me just finish doing this real quick. Top 10%. So that's a P of 0.1 to the right, or 0.9 to the left. However, we need to figure that out. And I have no idea where that's going to fall right now. I need to look up the z-scores that have a cumulative area of 0.9, and that'll at least show me where to get the z-score to get the other score. So if it's got 0.9 to the left or 0.1 to the right, it has to be a positive z-score. So I'm going to the positive z-table for 0.9. Point 0.9. Remember, if we have the area, we're looking in the center for a 0.9, right in between here. This one is clearly closer. This is 1.28. All right, so 1.28. If 1.25 is about there, 1.28 is about here. %10 to the right. So everybody who took this test and scores wherever the score is and higher may be hired. They're going to be looked at. So if you're not even in there, they're not even going to look at you. Okay, so I know the z-score is 1.28. How do I get an x back from that? Remember the formula, x equals x bar plus z, your z-score times the standard deviation. So our x bar is 50 plus the z-score I just looked up that's to the right, and the standard deviation for the whole thing was 10. We expect it to be between 60 and 70, close to 65. It apparently comes out to 62.8 as the eligible lowest score to get on the test to be eligible to be hired. Okay, does that make sense? So this is 62.8. They wanted 10%, top 10% is the same way as saying 10% to the right. If it's 10% to the right, then it's 90% to the left. Okay, so if you're looking up 90% to the left, it will give you the z-score that will be on the left. and you throw it in here. Okay, so this is P of 0.1. This is a P of 0.9. I hope you get that. All right, another one here. National Health and Nutrition Examination Survey reports that the mean pulse rate for women between the ages of 20 and 55 is 74.5 beats per minute, with a standard deviation of 12.2 beats per minute. Draw. Okay. Now, Alex is not going to ask you to draw. And right now you're going, yay. But the problem is, how do you know you're going to be right? How are you going to get a handle on what you're doing? Just be careful if you're not drawing. You know, maybe you don't need to draw. That is up to you. The project you need to draw, there's a couple requests for drawings on there. But you have to show your work somehow. So if, you know, if this is what you need, if this kind of thing is what you have, that's fine too. Kind of write some stuff down from the problem. I don't have to have this, but you're kind of proving it to yourself that it works. I mean, how do you, you know, I'm just going to keep recommending it. All right, let's see. This one had a mean pulse rate of 74.5 and a standard deviation of 12.2. And we are finding the percent of the women that have a pulse rate lower than 86.7. So I need to go up on this scale for a minute. What is 74.5 plus 1 standard deviation would be 12.2. So this, this is 86.7. So that's what they're asking about. So they said percent. So that means they want 86.7 to the left, and they are looking for the P. Okay. So remember the scores, that's 1 standard deviation. I just did the math. I added 12.2. 1 standard deviation got that. So that's clearly at a 1. So I could even use the empirical rule and add up a whole bunch of percentages in here, or I could just look up the 1. And it's a positive 1. So let me do that. So remember, a 1 even is 8413. 8413. If you're putting in an Alex, 841. What percent? Oops. So 84.1% is the answer for A. And then B says, by the way, if you add up the empirical rule, this is 34.1. 34.1, well, this whole side here is 0.5, so it'd be 34.1. Oops. Not in percent, in decimals, sorry. So these are percents. So if we make it a decimal, this is 841. It's the same as the empirical rule. Okay, be careful on the percentage versus the decimals. All right, this is 50%. So you could have gone 34.1 and 50%. 84.1%. Okay, using the empirical rule, or you can look up, excuse me. There's 1 in the positive table. So either way on that one, that works. Okay.